Hello everybody, my name is Kaj Niemi. I'm from BaseN. I guess half of you guys here probably know me from other occasions. I usually don't do speeches that much and presentations, but somehow somebody managed to sign me up here and I wasn't able to say no. You know, stories of life. Let's see.
You start with the full screen.
Yeah, nothing works.
No.
Business as usual.
No cause for panic. More bullshit.
Yeah. This is going to take a while, I guess. I made a small error with my PowerPoint, which is I used nice pictures. The problem was I didn't resize the pictures for presentation. I resized them for publishing. So the PowerPoint's about 100 megabytes.
87.8.
We don't do compression.
Yeah, we don't do compression. So I might as well, while you guys are waiting, do a commercial about BaseN instead. I mean, you guys are captive audience, right? After this, actually can tell me if I'm wrong, but I think there's a break afterwards, so
yeah.
You know, think of that as your reward for listening. BaseN has been around for about 11 years. I'm one of the founders, and my background is service provider. I used to work for a company called KPN Quest. Anybody recognize the name? Mm-hmm. Yeah, it went belly up a long time ago. It wasn't my fault though. What we sort of learned at KPN Quest was that we had about 26 and 27 countries in Europe plus a central backbone, and everybody was running HP OpenView, so we paid HP licenses, and everybody was running MRTG, and we're transitioning to RRD tool. And let's say 11 years later, most people know what the problem was with MRTG, which is scalability, and perhaps even with RRD tool, which aggregates data. And when you do this in, like, let's say 25 or 26 countries, and everybody writes their own stuff every time from scratch, and you, let's pick on the Italians, Marco's here, and there's the French, and there's the Dutch, and there's the Finns, and there's the Swedes, and there's everybody, and everybody has their own style of doing things. So you end up in a multinational company with 27 different network management, service management, whatever solutions. And that doesn't really fit my criteria for scalability. Pasi, who you guys know here as well, who's been introducing people here.
Get up.
Yeah, just get up. Just say hi. He's one of the founders at BaseN as well, and he used to be my boss at KPN Quest. And we have Niilo Neuvo, who I think most of the Elisa guys here know. He's one of the founders for Sci-Fi Communications here in Finland. And we sort of had an idea to sort of write scalable network management software. And we've been doing it for about 11 years. We mostly serve to very, very large service providers, multinationals typically, although we do have big Finnish service providers as well, and very, very large enterprises who run still their own networks. So they don't buy, let's say, MPLS from Infonet or Equant or anything like that. And part of sort of the network management software suits is that you have sort of the internal guys, and then you have sort of the external guys, and the external guys being the customers. So our stuff does actually both. So you get very, very nice white label portals. There's no basic logos or anything. Instead, you get sort of a very, very nice corporate logo of your environment, CSS. Everything looks like just as your guys' marketing department does that. But then again, you have sort of the back end, the back office side, which is for service provider environments, where you have geographical positioning for elements, scalability to, let's say, 3 million nodes, stuff like that, that, let's say, the RRD tools of the world doesn't sort of cover. And we do this as a service, and it's sort of selling internet makes it different. So you don't have to invest anything on your own. I don't know what this is. It's something else. I'm waiting for a PowerPoint actually still. So basically, there's nothing to invest. We sell it as a service. So the thing just runs on the internet, or if it runs in your data center, it's the same to us. It's our gear, it's our systems, our everything, it's your data. We do provide SLAs on it. It works pretty well. Largest reference customers, I think, Pasi can correct me if I'm wrong, but I think the three-letter company in Finland is a reference customer, right? Yeah. In Finland, DNA is one of the biggest customers we have in Finland. But they're pretty happy with it. In Central Europe, we have a company called GTS. That's also a sort of public reference.
Both
And
Finnish internet exchanges.
yeah, we have 100% of Finnish internet exchanges, which is like a woohoo. And we do have like 85% of the Finnish forest industry as our customers as well. So we do sell to big companies. I mean, I use it at home as well for power monitoring. So another thing that we do instead, on top of network management, is sort of we have looked into smart grid and water monitoring and stuff like that, where you have very, very large networks and very, very large amounts of data that you can collect. So we collect everything in real time. There's no aggregation of data. All the graphs are calculated on the fly, stuff like that. I think the PowerPoint is here. Let's see what happens.
Now it takes 3 minutes to load it.
Yeah, like I said, it's a 100 meg PowerPoint, my bad.
Take it away.
Do I just press space, or, I mean, how does it work?
Yeah, or those buttons.
Oh, those buttons?
Or space. Or those buttons.
So I think we can pretty much skip the introduction. You can ask questions at any time if you want. If you don't want to, I totally understand you guys. We did the overview, so let's skip that part. The presentation is sort of more about things, like I said, we do this as a service. So these are sort of some of my experiences or our experiences with IPv6. In general, things just work, which is sort of very, very nice for coming from IPv4. I mean, IPv4 has been around for, what, 20 years or something? And it's been, IPv6 works pretty much the same, really. Most of the things, yeah, let's skip that too. Let's skip that part as well. Most of the things sort of that we do, we try to do with a very, very low budget. We're not venture capital finance or anything. So anything that we sort of buy, we have to have a cash flow of sort of making it useful for. So we're using switches as routers, which means that we use smaller switches. We don't have like any chassis, big chassis switches. And there's the old theory, or sort of the proxim saying, you can take cheap, you can take faster, you can take features. Well, we took cheap and fast, which means that we don't have features on switches. Switches just forward packets for us. We use, Enterprise Linux 4 we used to use, Enterprise Linux 6 nowadays. We use actually scientifically Linux and CentOS because they are they're free. And I don't really like the sort of, we don't need the support that a commercial, let's say, Linux vendor would provide us. I wonder what happened there. This picture missing. This is your typical IPv4 LAN. Nothing special, right? You have HSRP, and you have a bunch of servers. They're connected to switches. Switches are connected in a layer 2 topology, and then you have two sort of one gateway sort of shared by two routers. In IPv6, yeah, so I don't think the OpenOffice thing really does show PowerPoints correctly. Yeah, can we do like PDF?
Just need to explain.
Yeah, we can. Well, it's hard to explain when there's IPv6 topology picture missing. But sort of, let's play around with the. We imagine that these are IPv6 addresses instead of IPv4 addresses. Let's see if this still works. Does this still work? No, it doesn't.
Even that.
Yeah, even that doesn't work. Very sad. So in IPv4, typically you configure servers statically, right? Typically. And your gateway is sort of always the last address or the first address, depending on how people tend to do their network network sort of numbering. Well, I can take a pointer, yeah. Mine doesn't work. Thanks. What do I press? Awesome. Okay. In IPv6, we do pretty much the same thing here, except usually you have, well, in IPv6 you have the default gateway as the link local address, typically, right? And there's two ways of doing this. You can put the global address on the servers, because you configure all the servers still statically. So there's a lot of typing for somebody to type in a very, very long global address on every server. So when we use HSRP or BRP for IPv6, we instead use FE80::1, which is used sort of link local HSRP or BRP address instead. And that sort of saves a lot of typing when you have very, very large LANs servers. And from our perspective, it sort of makes it easier. Let's see, I think this will not be a very nice slide presentation for you guys. Well, there's one unpleasant surprise that came along with this. There's a certain vendor, starts with a C, who has certain switches that when you configure IPv4 HSRP and IPv6 HSRP at the same time, tell you a very, very nice and clear error message. And this is not sort of very obvious. Yeah, all the pictures are missing is problem. Anyway, it turns out when you read the documentation, which we obviously didn't do, that you cannot have it on these switches at the same time enabled. It's sort of a hardware limitation. This is actually confirmed by TAC as well. So if you have IPv6 HSRP, it'll work. If you have IPv4 HSRP, it'll work. If you have both of them, it won't work. You have to choose one of them. And let's say for people sort of having an existing network topology and existing network, you either sort of upgrade switches, which means you put CapEx on the line, or then you sort of live without it. And this sort of, I think it's even present in X switches as well. I'm sure about E, but it for sure it's in 3560 with G, without G, 3750 with G, without G, and X series switches. And this was a really, really unpleasant surprise number one. Well, there's an unpleasant surprise number two. Multicast on EX series switches from a vendor that starts with a J also had issues. IPv4 multicast, which we use on our platform extensively, works fine, but IPv6 multicast sort of, it went into the switch fabric, which was proven. It didn't come out from the switch fabric. Turns out, if you configure, if you have IGMP snooping enabled on EX series switches, things go bad on older software releases. So what happens is that the switch eats all packets it doesn't understand. It basically just drops them. And this includes IPv6, includes certain protocols called ISO protocols like RSIS. Anything it doesn't understand, it just drops. This got fixed, I think, in Junos 11.4 or something, and this has been, it's been solved from day one on Junos. It was a very, very unpleasant surprise as well. Yeah, life is good again when you figure out that one out. I don't know, maybe it works for Flex Optics. For feature parity, remembering that we do network management as a service, everything we support for IPv4, we have to support for IPv6. Any kind of reception, if we do NetFlow for a customer, we have to have NetFlow for IPv4, we have to have NetFlow for IPv6. If we do SNMP, we have to do both. If we do XML, we have to do sort of any kind of thing that customers have that we support for IPv4, we have to have it on both protocols. This sometimes causes problems. In reality, it doesn't cause. In SNMP, it's a problem because the SNMP MIBs sort of tend to be very, very behind if you compare IPv4-based MIBs to IPv6-based MIBs, sort of with the IPv6 content inside. We have to be the first ones turning on IPv6 on a network, because if you don't have management capabilities of network, how can you sort of, if you don't have monitoring capabilities of the network, how can you sort of manage and get metrics out of your network? MPLS providers obviously going to say, you have 6P, and in reality it's an IPv4 network where you tunnel IPv6 on LSPs. Yeah, this is true, but there's a bunch of guys running IPv6, IPv4 networks natively, and you must sort of have feature parity, and sort of from day zero, whatever you have on IPv4 enabled for IPv6. It also means that we are the last guys turning IPv4 off in a network. So let's assume that in 20 years IPv4 is going to be end. We're going to be the last guys turning off the servers with IPv4 stacks. It's my assumption. I hope we don't need a fallout shelter. Hardening, this is again sort of, from our point of view, things that we do on our internal servers, internal switches, that are part of the service we provide to customers. If you have an IPv4 enabled switch and you turn on IPv6 sort of blindly, magically it doesn't sort of get protected automatically, which is really, really bad. So if you have control plane protection, you must take in account you have IPv6 packets coming in from somewhere. If you have a LAN, then you must have ACLs, assuming you do LAN ACLs. Dual stack servers must have IPv6 tables and IP6 tables and IP tables enabled. One is for IPv4 and obviously one is for IPv6. So in general, I must say that IPv6 is easy to have around. It's sort of trivial to configure nowadays. Operating system stacks support it really, really well on the features that we use, which is just 40 packets really. But there's sort of a lot of things around it that we need to always remember to enable. For most customers, RFPs are still very much a checkbox item. RFQ is included, but in reality, you don't have to deploy it. It's enough to say, we have IPv6 and everybody's going to be happy. It's a checkbox item. Very, very few providers on the planet really insist and demand that we do IPv4 targets and IPv6 targets. Most of them are happy with IPv6 targets only. IPv4 targets only. Same thing, very few customers measure and collect anything using IPv6. Like I said, on paper and in real life, we have full capabilities for everything, but in reality, most of the devices will be doing IPv4 polling. There is one organization in Finland that uses IPv6 exclusively. It's not a public reference though, but one of the guys have sort of bought the IPv6 sorry for full. And practically none have IPv6 only devices, so you have... We do. You guys do. That's true. So you sort of have an IPv4 track and you have an IPv6 track, and well, I don't know what happened here, but something. But
he said practically.
Yeah. But in Europe and in America, sort of the IPv4 exhaustion doesn't seem to have sort of applied to everybody yet. You guys mostly service providers here, so I mean, my guess is everybody has a lot of IPv4 addresses stashed around PA allocation somewhere beneath the pillow or something. So I haven't seen anybody sort of selling screen, but we need to do CGN except the mobile guys. Kalle probably has CGN somewhere, right? Yeah. Or some kind of net, but most of the guys are still happy with public IPv4 addresses. Ripe still has a few days left, I think. That's pretty true. What?
Well, we'll have a right member say something about, or right presenter say something about that, maybe?
I don't think so.
Okay.
It's confidential?
It's not.
That's pretty much the end. There's going to be a nice picture here about food and stuff, but it got missing. No worries. Thank you very much.
What's the PDF and you see now?
It's 40 megs.
70 megaa.
Yeah.
Tässä on kaikki kuvat.
Yeah, there's the watermelons waiting for you guys. Thank you.
Any questions? Any questions? Well, so I know you've been here before, so we got you something else because we know you already have a towel.
Okay.
So we got you a TREX colored thermometer. The way it works is that there are several different weights there, and some weights go up and some weights go down, and the one that stays lowest up tells what the current temperature is, and it's very accurate.
It's 24 degrees?
Yeah. And please be aware that it's not meant to measure your body temperature. It's meant it's meant for room temperature only.
That's what they all say.